All right. Before we continue, any questions regarding the homework, exam, quizzes, anything? Anton?
I had a question about the exam. I don't know if I'm allowed to, or if you're allowed to answer it or not, but I was kind of wondering how many questions to expect on the exam.
Okay. So the exam will be 4 pages. It's 3 questions per page. When I say questions, I mean something similar to what you had in the quiz. Okay. If it's harder than the quiz, maybe you have fewer on the same page. And if it's way easier than the quiz, you may have 7 or even 8 if they're just something I'm looking for short answers. Okay. So, but roughly 3 questions per page. Yep. Nathan.
If there's any more questions about the exam, those can be asked now, or else can you do 2.7 number 10?
2.7 number 10. Let's say this. Lower your hand if it's not a question about the exam. Let's answer every question from exam first, so people can stay focused. Yep. All right. Does everybody know how to submit the exams online once you scan it? Who hasn't submitted anything? Yeah, Emma?
I was just wondering, like, how are we going to get the exam? Are you going to, like, post it and then we can just...
Yeah, let's talk about that. Yeah, let's talk about that. So tomorrow we start from 11 for the usual class, right? So what's going to happen is at 10:55, you will receive an email from me, okay, with a PDF of the exam by email. So make sure you check your email. Okay. Once you have that, it's gonna be something look like an exam, and then what you do is you take out a paper of your own, and then start just writing your answer down. Tell me which problem and what's the answer. That will go from 11 all the way to 11:55, which is regular class time. Write the answer on a paper. Once you finish that, I will give you another 10 minutes, which is 11:55, all the way to 12:05. That's when you scan your answer. You take a picture of your answer, whatever. So just make a digital copy. If you have multiple pages, just take multiple pictures of it and submit it on Canvas. Let me show you how to do it on Canvas. So, yep. So if you go to the your course, click assignment, and this is the upcoming assignment, and you will see your homework is due 12:05. That's when the exam is due. And then you have a button here, which is called submit. You click it. You will have a thing asking you to upload something. So you just click this one and then upload the picture you just took. Okay, if you have multiple, you can upload multiple. And then once you finish, put your comments here. Sometimes you just say, hey, I answered number 2, but then I cross it out. Then I add it in the back. Some comments like that, just put it there. Anything you think I should know. Okay, then you click submit. And the Canvas should tell you if your submission is successful or not. Okay, and don't worry if you mess up. You mess up, you can resubmit it again, as long as it's before the due time. Sounds good? Yep, that's how you do it. By the way, tomorrow when you are taking the exam, I will be actually in this room link. So if you find any question halfway when you take the exams, join this room. You will find me here, and I can address your question right away. Okay. And don't worry too much about the format. If your internet breaks, whatever, don't panic. We will always figure a thing out. Worst case, we just let you retake it again with a different format. Okay, so don't even worry about it. Anything happens, we can handle it. I cannot promise you that nothing is going to happen. There is definitely going to be some problem. Okay, but good news is we can handle it. Cool, Addie?
Like work-wise, how much work are you expecting us to show?
Reasonable level.
Okay.
Don't just tell me like the answer is 2 and ask why. You just say, trust me, I'm good. So the answer is 2. In that way, even you are correct, I won't give you any points. So you somehow you show something reasonable and use your best judgment. I would say the safest way to do it is you do it in the way I did in notes.
Mhm.
Of course, that's too much. Okay. But I would say roughly 70%, 50% of what I write in the notes will be fine. And it really varies from person to person also. So yeah, some people are just quicker with, for example, timing the conjugate, so they skip a steps. Just do everything that you think is reasonable.
Okay.
Eddie? No. Quinn? I can't hear you. Can you check your mic?
Oh, so would you like us
Yep.
to join this Zoom call while we're taking the exam, or is it just for questions?
Hold on. I didn't hear you at first.
Oh, I'm sorry. Would you like us to join this call during the exam while we're taking the exam, or is it only for questions?
It's only for questions. I know some professor ask you to show your face when you take it. I found it pretty interesting. So I don't have the bandwidth to look at all the faces at the same time. Yeah. So it's all for your benefit. I don't want to monitor anything.
Thanks.
Yeah. Nick?
Do we have to rewrite the question or the problem?
No. Tell me it's number 1. Index A. That's all you need. Okay. Last call for questions regarding the exam. Anything regarding the exam, content, format, anything.
Which lesson is
Yep.
it up through? Like 2 point what?
2.1 to 2.8.
2.1 to 2.8?
So that's the last, just to tell you, like that's the last section of chapter 2. So we stop right before we introduce the differentiation rules like power, exponential, whatever we're doing in chapter 3. Okay, right before that. Also, 2.4 technically is not covered except that one question, which is number 6 in quiz 1. Basically, write down the precise definition of limit fx equals L. That's the only thing I'm going to test about 2.4. Okay, just to mention it. Adam?
Could you go over the number 6 on the quiz 2?
Okay, so before that, any more questions regarding the exam? Otherwise, I'm going to start doing this. DJ?
Yeah, can you hear me?
Yep.
So I might have missed this, but you said it's just 2.1 through 2.8. So does that mean we can't use like the product rule or the quotient rule when we're finding derivatives?
For this exam, no.
Okay, so
Starting
it's always
from,
gonna
yeah,
be
once we pass the first exam, feel free to use whatever you use. I would say pay attention to how I ask the question. For example, please find the derivative of x squared using the definition of derivatives. That's a clear indicator you should go with the limit h goes to 0 approach.
Okay.
Yeah.
All right, thank you.
Does that mean we can't use the power rule too?
If it's the definition of the derivative, you need to ask yourself, what is the definition of the derivative, right? So technically, I'm not looking for the derivative. I'm looking for, do you know the definition of the derivative? Not what the actual derivative is. That's not the focus of the exam, yeah. All right, Adam, you said quiz 2 with number 6. Correct me if I'm wrong. Otherwise, I'm going to go ahead and try to do it. 6. 6, 6, 6. Okay. Use the intermediate value theorem. To show that fx equals has a root between 0 and 1. This is a question that I'm trying to test you. Do you understand how to use the intermediate value theorem? Okay, and do you understand what it is trying to say? Now I realize I didn't share my screen, did I? Oh, okay. All right. Okay. The key is you need to understand what intermediate value theorem says, and also what are the preconditions you need to satisfy. So here's the thing. Number one, let's see. You basically want to show fx equals 0 for some x in 0 and 1. So the first thing you want to show is fx is continuous on 0, 1. Okay. Number two, what you want to show is you want to show, remember the AB and FA, FB thing? A, B, FA, FB. Okay. You want to show this one can hit any number between A and B, between FA and FB. You want to show this one hit 0, then you better show that FA 0 is between FA and FB. More precisely, F0 and F1. Okay, so now let's just calculate F0. Less than 0. Bigger than 0. So on the left, it's less than 0. On the right, it's bigger than 0. Therefore, it crosses. For some x between 0 and 1 by the intermediate value theorem. So what I'm looking for are the two conditions you need to check. Continuous, and then the number you're looking for is actually between the starting and ending.
Okay, so would like say a question like this was on the exam, would you want like the graph as well, or?
Not really. This is for
Okay.
my illustration. So technically optional.
Okay.
Just think about this. Okay, taking an exam is almost like doing an interview. I can ask a question. It's up to you to show me that you did get my question and you know how to show that actually you know what I'm asking and you know how to answer the question. Sounds good. So use your best judgment if you kind of feel like, yeah, is this what Dr. Chen wants? It's more like, what are you trying to show here? Okay. Cool. Austin?
Can you go over question 2 on quiz 2?
Quiz 2, question 2. Okay, from now on, let's finish every question from the quiz first and then web work. So yeah, raise your hand if you have questions in the quiz. And let's finish them first. Dropbox. Oh, here. Quiz 2, number 2. Is the following function continuous at x equal to 1, 2? If yes, justify your answer. If not, determine. Okay. This is the function. The point of interest are 1 and 2. So for continuity, there is only one thing we check. That is, does the limit equal the function value? Okay. Similarly, does the limit equals function value at f2? To do that, especially for piecewise defined function, you'll need to check the left and the right. So for this one, on the left, what we really should look like is 1 squared minus 1, which is 0. On the right, we should look for this formula, which is 1 minus 1 squared, which is 0. The left equals to the right. Therefore, limit x goes to 1. Fx is 0. What is f1? Now we go to this. That tells you what happens exactly at 1. f1 equals 2. Are they the same? No, then not continuous. Moreover, it's a hole. There's a hole. The terminology you're looking for, it should be removable discontinuity at x equal 1. If that is okay, we do exactly the same thing for 2. On the left, okay, I'm going to close the door. Limit x goes to 2 plus fx, which is e to the square. I don't know what e to the square is. Clearly, it's not 1. So they're not the same. Of course, it's not continuous. Moreover, on the left and the right, you don't have the same number. It's a jump. Discontinuity. At x equal 2. That's number 2. Okay, for type of discontinuity, make sure you have the list. It's a jump, it's a hole, it's a vertical asymptote. Okay, we only have the 3 conditions. And oscillation, of course, but it's going to be rare. Nick?
Number 3 on quiz 2.
Find this. All right. It's a limit at infinity. First plug in, you have infinity over infinity. Now you know leading terms. If I put this one as a formal question, you have to show the work. Okay, so it's not the quick leading term thing. Then, what's the leading term on top? X. What's the leading term on the bottom? Square root of x squared, square root of 3x squared. Both of them give me x. Okay, therefore, divide by x here, divide by x here. Three minus 1 over x. square root 1 minus 2 over x square, square root 3 plus 0, 0, 0. I would say this is a typical example of how much work you need to show in the exam. Clearly, I skipped a lot of steps from here to here. Assuming you're already quick with algebra, feel free to do that. Okay? But you did show 2 essential steps. Number 1, you show me, you know what the leading terms are. So if this is 10 points, you write down this up and you mess up with this one, I still give you half the points because you know what the leading terms are. Okay? Second, just show people, before I take the limit, what the final thing looks like. Because after that, I'm going to apply the fact, that is, these are 0. Okay, so all the essential ideas are presented with all the elementary algebra skills skipped. I would say this is a perfect balance. Of course, you can go ahead and try to rationalize this thing by timing the conjugate. For our class, we don't require that. Sometimes this is actually easier. So stop here. Cool. Any other questions regarding the quiz? All right, let's go to web work and everything else. Aaron.
3.1, number 8.
3.1, number 8. Differentiate the function this. Okay. Okay. So this is the typical problem. And if you feel like s is confusing, you can change it to x to the 15. They're basically the same thing, but a different name. With that in mind, let's take the 12 out. What you're handling is just 1 over s to the 15. Moreover, you should change it to a power because that's the only thing you know, and now it's clear. In our class, you can either do this or you can change it to 1 over s 16. I have to say, it really doesn't matter whichever way. So yeah, just take whatever you feel comfortable. Right, Nathan?
You can do 2.7, number 10.
Number 10. Compute the following. Okay. Oh, okay. So this is what you know. You know the tangent line of fx at -4 pass through -5, -7. Your question is, what is f -4? What is f prime -4? Okay. To solve this, first, you know x equals -4. What's your corresponding y? Now take a look. This one is on the function, right? That tells you when x is -4, your y should be 4. Second, you were looking for the derivative, but you don't know the formula. What do you know is instead you know the information about the tangent line. So what you need to do is just find the tangent line slope at -4. And what do you know about this line? It passes this point and this point. Therefore, the slope is given by -7 minus 4, -5 minus -4, which is positive 11. Okay, so the key here is try to know the association between the slope and the derivative. All right, Emma?
Can you do 2.7 number 4? Just one of the letters.
Four. The displacement in a particle. Dun, 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 dun. Okay. So basically what you're trying to do is you have something which is st equals 4 over t squared. You are trying to find s prime t at t equals a, 2, 3, and 4. What I would suggest is just do this for once, and then you plug in a equals 2, 3, and 4 once you finish the first one. Okay. Now the rest is just doing it by definition. Later, you can do it by power rule. Clearly, this is t to the -2 power. So you should for t to the -3 power with a -2 times a 4, something like that. But for now, definition. So, no, 8. There's no shortcut, so let's write it down. A plus h, a plus h. By the way, if you just write this down, I'm going to give you 3 or 4 points because you know the definition before you start anything. Okay. So think about the cost of skipping steps. Let's don't do that. Common denominator. Then divide by h again. On the top, FOIL everything out. And you will find the first term cancel out. Okay. They all have h. So cross out, cross out, cross out. And when h goes to 0, this part is gone. When h goes to 0, a plus h squared will become a square. So this is -8, 8 cube. Now plug in 2, 3, 4 for the rest. Okay, like we mentioned, you're just doing the derivative of this, which is nothing but 4 times t to the -2. Now, if we know the power rule, this becomes piece of cake. Okay, and then it's -8 times t to the -3, which is way better than difference quotient. Okay. Other questions regarding the homework? Correct. Polynomial. No. Let's just say this. What we have so far? We know how to handle polynomials by doing power. We know how to do that. Rationals. We actually know already how to do that using quotient rule. Think about it, right? It's just quotient rule. So this is easy. Exponential, we already know how to do it. Okay. Trigonometry is missing. All right. Now, square root of x, which is the inverse of the things like this, is doable because it's nothing but another power. These two are missing. So inverse of x, inverse of trig. So all the 7 simple functions, these ones are already done, leaving us 3 more. Okay. Now what we're going to do is we're going to teach you how to do trig. Then we're going to teach you how to do inverse. Once you know that, you can get log from exponential, you can get trig inverse from trig. So everything is done. Now for differentiation rules, we know how to f plus minus g. We know how to do constant times f. We know the product rule. We do know the quotient rule. So the only thing missing is going to be f circle g. Okay. So what are missing will be 3 sections. The first section is going to be how to do the trig. The second section on how to do the composition, the last differentiation rule. And the third one, we will talk about how to do inverse. After that, we will know how to do log and the trig inverse. So 3 more sections, and then the whole thing is over. Sounds good? Let's start with trig. Derivative of trig functions. Question: how many trig functions do you know? Okay. You should know that really quickly. 6. They appear in pairs. Sin x, cosine x. Oh. Based on that, we have tangent x, we have cotangent x, and then we have secant x, we have cosecant x. For this section, we find the derivative of all the 6 of them. Second, the good thing about trig is they satisfy a certain relationship. For example, tangent x is nothing but sine over cosine. And then you say, wait a second, this is a quotient, right? I know quotient rule. Which is f prime times g minus f g prime over g squared. Seems like once I know the derivative of sine and cosine, I can get tangent for free with some additional work, not for free, but it's pretty easy to do using something I already know, which is the quotient. Sounds good? Similarly, what about cotangent? Well, cosine over sine, quotient rule. What about secant? Secant is 1 over cosine. Not only is it a quotient rule, it's an easy quotient rule because the top is just a number. Okay? From here, can you see that? Even though we have 6, but really, well, focus should be here because the rest can be get from once you know sine and cosine. Okay? Now you have sine, you have cosine. Do they have a relationship? Well, let's take a look. What's the graph of sine? What's the graph of cosine? According to our experiences, they are exactly the same graph. They are exactly the same. That means they have exactly the same derivative. Make sense here? If you have the same graph, you have the same changing rate, of course. The only difference is once you finish the first one, you need to shift it to the left by pi over 2. Written inverse, cosine x is actually sine x shifted to the left by pi over 2. To make this point goes here. The rest will be straightforward because they're basically the same shape. Sounds good? If they have this kind of relationship, I think it makes sense for me to first find the derivative of sine x, then also shift it to the left by 2. Actually, I use this. By pi over 2. I should get the derivative. Sounds good? All right. So this is our analysis. Actually, you have 6. 4 of them can be get out once you know these two. But technically, once you know this one, you know the cosine. And once you know sine and cosine, you know tangent, cotangent, secant, cosecant by quotient rule. Sounds good? So this is how we're going to do it. I'm going to teach you how to do sine x, which is pretty long. Okay. We go over it for once. Once we know that, I will leave it to yourself. We can actually practice in class how to do the other 5 as an exercise from quotient rule. Okay, that's our plan. Then the first thing is, what is the derivative of sine? By the way, that's the beauty of mathematics or any logic thinking. That is, you have 1,000 things to worry about. But when you narrow everything down, you find there's only one key point. Once that thing is done, everything else can follow. So that's what we call a breakthrough. For this case, the breakthrough is sine. All right. The first thing is try to do what we can. This is sine. Do you remember the old game we played at the beginning? That is, I draw the function and you draw the derivative. It's not going to be accurate. It's going to be roughly giving you the shape. Sounds good? Let's see, just by drawing, what the graph should look like. Well, first, pay attention to places where this one is flat. That's where your f prime equals 0. Right? Okay, that's going to be here. Here. And here. Moreover, actually, if you know sine, you know where they are. So you can put it here. All right. Now second. Let's look at in between. Between this point and this point, your whole thing is shaped like that, right? Can you see the whole thing goes down? That means your derivative should be below. Okay. Second, your derivative start from 0. Your derivative return to 0 after a while. Then your whole thing should somehow look like a shape like this. It's below. It starts from 0. It goes back from 0. Okay. Similarly, what about the second part? It's increasing, so it's above. Moreover, it starts from 0, it ends at 0. So above and increasing, meanwhile, it looks nice. It has to be this way. Does that make sense here? Okay. Moreover, if the original thing is periodic, which means nothing repeats itself after every 2 pi, do you think the changing rate should also repeat itself after every 2 pi? Therefore, if I can finish one, I can finish all. By just doing by abusing the property of periodic. This is my guess for the derivative. What do you think it is? It's a wave. Moreover, this one starts from here. It hits 0 here and here. This one looks like cosine. Sounds good? Okay, that's the beauty of just drawing. You kind of roughly guess this one roughly is a wave, and moreover, it looks like cosine. Of course, maybe cosine is like that, but your real thing is like that. Okay, it's not exactly cosine, maybe 2 times cosine, maybe just share the roughly the shape, but not the same shape. That's for later. But for now, I think this is a pretty reasonable expectation. Okay, of course, later when we show, we will realize they are exactly the same. Okay, so that's beautiful. The derivative of sine is cosine. Sounds good? Okay, of course. This is just a rough idea. We need to go over a proof to tell people it's exactly cosine, not something like cosine. It's cosine. And there is nothing better. By the way, this one is going to be long. It's going to test everything you have stored in pre-calculus up to this moment. So let's see how much you can remember. Okay. This is the definition. It's not good. Why? Because I want to do algebra. If I want to do algebra, I really wish something has sin x, something has another sin x. I pull the sin x out, and then I put a parenthesis, and eventually something nice happened here, hopefully. Make sense so far? For now, I can't do nothing unless I can take this one and somehow get a sin x out of it, and maybe some side product. Still makes sense here. Do you remember any formula? We'll take this one and somehow give you sin x. When you have some angle plus some angle, it gives you each angle. A dot, 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 dot. From pre-calculus. Anything? If you know it, just say it. Yep, Aaron.
Is it sine A times sine B equals sine A plus B?
A times sine B plus cosine A cosine B, something like that, right?
Yeah.
Right. That's the right reflection. Okay, we do have something like that. Does everybody record now? Okay, it's called summation of angle. The next is go online and Google summation of angle. You will find this is not the correct one. Close enough though, because we have sine and cosine, right? We have a lot of them. For this one particularly, we should look for, the formula looks like sine A cosine B plus cosine A sine B. Then this one. It's going to be sine A, which is sine X, cosine B, which is cosine H, plus cosine A and sine B for X and H minus sine X. That's something we can do. It looks worse because it's longer, but the good news is this time we do see common factors. Here. Okay, do some algebra. You have some side product. We don't like it, but we have to keep it. Still okay? Now here's what I'm going to do. I'm going to take this one and name it number 1 and then name it number 2. Let's use Greek Rome letter to make it sound important. And then write it here for 1. Second, suddenly I realized this one has nothing to do with h. H goes to 0, h doesn't go to 0. This one stay the same, so we can take it out. So finally, we have something look like this. Similarly, we have a second one. This sin x we can pull out. It has nothing to do with h. What we really care about is limit h goes to 0. Cosine h minus 1 divided by h. Sounds good? Okay, now our job. Figure out this limit. Figure out this limit. Then done. Second, later we will show. If you know the limit of the first one, you can use it to find the limit of the second one. Still okay? So the key is try to find this. And I'm not gonna lie, this one's gonna take long. Okay, but let's see how we do it. We do it by geometry. I will give you the answer first, of course. How to say? Fact. Limit h goes to 0. Sine h over h is 1. That's a fact. We will try to prove that. And later we will show this is also an important fact. Okay, so we need to know it. Sounds good? Okay. Now to show this with sine, cosine, and h, we always go to unit circle. And we only need half of it. Wow, that's bad. Yeah. Okay, one last time. Okay. We want to be smart. We put h here, which is the angle. We put a red line here to indicate that's the one. Edge in a circle. We'll take a blue one to indicate the arc. Finally, we extend this triangle and have a green one. So we have 2 triangles and 1 sector. Good so far? Now I'm going to show you how to prove the limit using the relation between the red, the blue, and the green. Let's start with the red. The red is in a triangle, clearly. The hypotenuse is 1. Let me draw it in the same color. Good so far? Do you know how to calculate h? If you know this is 1 and the side is h, the angle is h, it's actually very easy to do. This is sin h. Sounds good? All right. Now let's check the blue. The blue one is a sector. So technically, this is an arc. We know this is h, and this is 1. Does anybody remember the arc formula? Okay. Hopefully you will know all the formulas from Calculus 1 when we finish this, okay? You need to accumulate that, which will make you better. But it's actually not hard to see. This is a circle. Do you know the formula of the circumference?
2 pi r.
2 pi r. That's for the whole circle, right? What about just for an arc? That's just part of the circle, which means the circle times a fraction. Still okay? Now you just need to figure out how much percent of this arc compared to the whole thing. That corresponds to actually how much this angle is corresponding to the whole angle. Make sense so far? That proportion is going to be h divided by 2 pi because the whole thing is 2 pi and the angle we have here is h. For example, if h is pi, it's half the circle. If h is pi over 2, 90 degree, that's 1/4 of the circle. Make sense here? All right, so that is the form of the arc. You simplify a little bit, delete it. Oh, not delete it, cross it. We have RH. RH, which is 1 times h because we're using unit circle, which is h. That's the red. That's the blue. Good so far? All right. Look at the graph. Which one is longer, red or blue?
Blue.
Blue is longer because it's an arc. Red is a straight. Blue is like that. Definitely blue is longer because straight line is actually the shortest, right? So this is what we have. Blue is longer than red. What is blue again? Blue is h. What is red again? Red is sin h. Okay? What are you trying to prove again? You're trying to show the limit of this over this. So how about we just divide this one to the other side? And it's less than 1. That will be the first fact. By comparing these two sides, we'll reach this conclusion. Sounds good? Question. Our goal is to show this one, h equals 1, when h goes to 0. Good so far? We already showed this one is less than 1. What else do we need in order to show this one is equals 1? We just need to give the other side and say, hey, it is 1 also. I'm less than 1, I'm bigger than 1. What's the conclusion? I am 1 by squeeze theorem. Sounds good? This is the final goal. We have the other side. Now we just need the left side. That will result in from comparing the areas, and we will do it next time. Okay? That's all for today. We're halfway.